Hi everybody, Mrs. Phillips here, one of the math teachers at FCA. I'm here to go over some problems from the Unit 5 practice test with you so that you can be better prepared for your next lesson, which is the Unit 5 test. Remember, these problems are directly from the practice test, so make sure that you're using them to help you complete the practice test and get ready for the actual test. All right, here we go. So first topic is equivalent ratios. It's important to understand how to go from one ratio to another. Ratios are another way of referring to fractions. So these are all ratios written as fractions. We're looking to see which ratio is equivalent to this 2/16, and these would be our answer choices at the bottom. So in order to write an equivalent ratio, what you need to do is either you're going to multiply or divide by the same number in the numerator and the denominator. So for instance, or for example, we could take our ratio 2/16 and we could test this out and say, well, what if I multiplied it by 2 on the top and the bottom? Remember, the rule is whatever you do to the top, you have to do the same thing to the bottom, right? So an equal ratio to 2/16, if we multiply it by 2 over 2, 2 times 2 is 4. 16 times 2 would give us 32. Unfortunately, that's not one of our choices, right? But this is how you determine or how you get an equivalent ratio. And the reason it's equivalent is because anytime you multiply or divide by the same number, top and bottom, okay, think about this as a fraction, 2 over 2, right, or 3 over 3, or 4 over 4, every time you have the same number in the top and the bottom, it's equivalent to 1. So when you divide or multiply by 1, it keeps the value, right? So if I had 17 times 1, it still equals 17, right? If I had 17 divided by 1, it still equals 17. So all you're doing is you're replacing this number 1 with a fraction. And the fraction that's a fraction that's equivalent to 1 would have the same numerator and the same denominator. So 17 times 2 over 2, right, is the same thing as multiplying by 1. It would still equal 17. All right, so let's figure out which one of these choices down here at the bottom is equal to 2/16. We're going to do that by taking a look at the numerators to help us get started. So to get from 2 to 6, we would have to multiply by 3. So let's test that out. Does 3 work for the top and the bottom? If I have 2/16, remember, I got 3 from 2 times 3 will give us 6. That's what I'm trying to figure out if this will work. So the top works times 3, but 16 times 3 does not equal 64. It's not big enough. Okay, so therefore this ratio is not equivalent. So put an X down here. How do we get from, I'll extend this line a little bit to separate them. So how do we get from 2/16 to 8/80 to test this out? Again, look at the numerators to help you out. How would you get from 2 to 8? You would multiply it by 4, right? So let's test it out. Remember, top and bottom have to be the same. 2 times 4 equals 8. 16 times 4 actually equals 64, and so therefore this does not work. Okay, both the top and the bottom have to match. So option 2 is out. Let's try option 3. Again, starting with our 2/16. And now we are looking at the numerators. How do we get from 2 to 10? Okay, this one would be times 5. 2 times 5 gives us 10. And 16 times 5, if you need to, grab your calculator, of course. And this actually works. 2 times 5 is 10. 16 times 5 gives you 80. Therefore, this would be the correct choice. Now, looking at the fourth option, while we have this problem up here, okay, if you notice the numerator is getting smaller, right? That's a clue that you're going to need to use division in order to test this out. So 2 divided by what would give us 1? That would be 2. 2 divided by 2 would give us 1, right? If I were to divide by 2 on the bottom, 16 divided by 2, that's going to give me 8. Therefore, that is not equivalent. It will not work. So equivalent ratios need to be either multiplied or divided by the same number, top and bottom. That's the rule to remember. All right, let's go on to number 2. Next, we're talking about the constant of proportionality. So there are a few questions on the practice test and on the real Unit 5 test dealing with the constant of proportionality. The big idea that you need to remember is that the constant of proportionality is when x equals 1. That is when the constant of proportionality occurs, all right? So sometimes they're going to give you a chart, and your job might be to find the constant of proportionality. Remember, the rule says x has to equal 1. So we're looking at the chart. Here's our x values. Oops. Every time you draw an arrow in here, it like makes it an official arrow for you. So these are my x values on the top, right? And remember, I'm looking for when x equals 1. So here it is right on the chart, okay? Therefore, my constant of proportionality would be when x equals 1, y equals 5. And you could write it like this if you needed to. When x equals 1, sorry, my mouse is being a little weird, and y equals 5. That's supposed to be a 1. That's a little squiggly. All right, so the key to remembering constant of proportionality is when x equals 1. Okay, that's what you're looking for. Whether it's a table, a graph, an equation, which we're going to talk about in a second here, doesn't matter what form they give it to, you know, what example they give to you, x has to equal 1. That is when you can find the constant of proportionality. So if you have an equation like this, right? Remember, your smart brain is thinking x has to equal 1. So if I plug in 1 here for x, what will y equal? Right? There's a question just like this on both the practice and the test. So if I plug in x as 1, remember that's the constant of proportionality, right? What will y equal? 16 times 1, well, y will equal 16. If you needed to write it as a coordinate at an ordered pair, you could write it as, remember, x equals 1, right? And we figured out when x equals 1, y will equal 16. So the key to this is remembering always that the constant of proportionality is when x equals 1. Then you can go from there based on a chart, a graph, an equation, whatever it is. All right, let's look at number 3. And this is talking about comparing unit rates. So again, this question is right from the practice test, and there's one very similar on the actual Unit 5 test. This says, Sarah and Yanni are comparing what they get paid at their jobs. Sarah gets paid $80.70 for 6 hours of work, and Yanni gets paid $72.50 for 5 hours of work. Find each constant of proportionality and compare them. So again, when x equals 1, right, that's what they're talking about here. What are they getting paid for 1 hour of work? Okay. So the way that we do this is, let's grab one color for, we'll do blue for Sarah. I'm just going to put an S for Sarah. Okay. They told us that she gets paid $80.70 for 6 hours. Okay. So they're talking about money. I'm just going to use a dollar sign per hour. Sorry if it's a little sloppy. Okay, so money per hour. The per part means division. So this is going to help you set up your division in order to find the unit rate. We're going to plug in the information from the problem according to what they're talking about, money per hour. So the money divided by the hours. All right, so for Sarah, it's $80.70. Oops. I don't know why my mouse is being so weird. Sorry. $80.70 divided by 6 hours. Grab your calculator. I'll bring up the calculator here. So we've got $80.70, right? Divided by 6 hours. And that's her hourly rate. She's making $13.45 per hour, right? I'll move that over there for a second. So $13.45. Remember, we're finding money per hour, right? So this is the amount of money she makes per hour. All right, let's find Yanni's hourly rate. So we'll do this in green down here. Y for Yanni. And again, we're setting it up the same exact way. We're doing money per hour. So we're going to take the money he makes, $72.50. The per, remember, means division. So $72.50 divided by, and I'm getting this right from the problem. Whoops. Again, my mouse being weird, sorry. Divided by 5 hours. Grab that calculator. So we've got $72.50, and then divided by 5 hours, and we get 14.5. Now remember, in money, okay, money goes to the hundredth place. So when we write this amount of money, it's actually $14.50. Okay, we could add on that 0 for that hundredth place because, just calculating it equals 14.5, but we're talking about money, so we're going to write it as an actual amount of money. So this means that he makes $14.50 per hour. So the question is to compare the amounts of money that each person is making, right? So $13.45, $14.50. We can compare these by saying either Sarah makes less, right? She makes a little a dollar and change less, or we could say that Yanni makes more money because he's making a little over $1 more than her, right? So finding the unit rate involves division. However the problem is set up, okay, in this case it's money per hours. That's how you're going to set up your division, okay? If it were, think of another example, like the amount of words you write a minute, right? You could do words divided by the minutes, or pages you read, pages divided by the time, okay? So however it's set up, look at that to help you set up your division, divide it out, and this would be the unit rate for each person, how much they make per 1 hour. That's what unit rate means, per 1. All right, let's look at number 4. Topic number 4 is about proportional relationships, and this is the last one. Yeah. So proportional relationships can be presented in a table or a word problem. We're going to do one of each because they are both on the practice test and they're both on the actual Unit 5 test. So the question would be, are these numbers proportional? Okay, are they related to each other proportionally? Meaning, do they have the same relationship between the x's and the y's? All right. So the way to look at this is just to find out one way to look at this is to find out how do we get from x to y. Okay. In this case, 8 to 4, you have to use either multiplication or division. You can't use addition or subtraction. Okay, so multiplying or dividing. How do we get from 8 to 4? Well, we can divide by 2 to get from 8 to 4. And then we're going to test out to see if that will work for the rest, okay? In order for it to be proportional, they all have to have the same relationship. So let's see, can we get from 14 to 7 by dividing by 2? Yes, that will work. 14 divided by 2 gives us 7. 7 divided by 2 will equal 3.5. If you weren't sure, you could always grab your calculator, right? And we could do 7 divided by 2, and that will give us 3.5, right? You could test it out. Remember, take advantage of, being able to use a calculator, right? You have it available to you, so use it. Same thing with 9, so we can test it out. 9 divided by 2 does give us 4.5. That works. And last one, hopefully this one you can do in your head, right? It's a basic fact here. 10 divided by 2 does give us 5. So because all of them work using the same exact operation and the same number, then we would say that yes, this is proportional. This whole entire table is proportional. Another way to look at this is to see if all the fractions that you can make, or ratios, are equivalent to each other. So 8 over 4, 14 over 7, 7 over 3.5. We could set them up as ratios, and we would want to know if they're all equal to each other. Okay? And then 10 divided by 5. So again, right, grab your calculator if you need it. Okay? And all of them, when I divide them, they should all have the same answer. So 8 divided by 4 gives us 2, right? 14 divided by 7 would be 2. You could test it out in the calculator. 7 divided by 3.5 is also going to equal 2, and so on. They all equal 2. So they are all equal to each other, and that is how we know that they are also a proportional relationship. Every single one of these are all equal to 2. All right, last bit here is the word problem part. So this one's a little tricky. Oh, and it didn't, you know what? Sorry, it didn't copy over as fractions. So this 13 should be 1/3. When I copied the problem over out of the lesson, it made them whole numbers. And this 12 should be 1/2. Sorry about that. Okay, so it says Marcus needs to mow his rectangular shaped backyard. If he can mow 1/3 of his backyard in 1/2 hour, how long will it take him to mow the entire backyard? So 2 ways you can do this. One, I always like drawing myself a picture. So we can take his yard, and he said he's going to mow 1/3 of it. So I can split this up into thirds. Right, each piece is a third, making it 3/3 would be the whole. And it said in the problem that it's going to take him a 1/2 hour in order to mow 1/3. So let me just change colors. And so each third is going to take him a 1/2 an hour. So 1/2 an hour for that one, 1/2 an hour for this third, and then another 1/2 an hour for this third. So the question, right, it's saying how long will it take him? Well, if we add up all these halves, a 1/2 and a 1/2 gives us 1 whole, and then another 1/2 altogether would be 1.5 hours. If you don't like the picture method, there is a proportion that you can set up. So another way to solve it, I'll draw a line here to separate it, is to set up a proportion. Okay, they told us that he can do 1/3 in a 1/2 an hour. So this is 1/3. We'll just put Y for the yard in 1/2 an hour. We want to label it so that the other side is set up correctly. Okay. The question's asking how long will it take him to do the whole yard, right? So 1 whole yard equals how many hours? In order for a proportion to work, you have to set it up with the same unit on the top and the same unit on the bottom. So we've got the yard, the piece of his yard on the top, and then the hours on the bottom. So what you would have to do, kind of like our equivalent ratios, is you're thinking about, well, how do I get from 1/3 to 1 whole? Okay, you could think about our picture. How many thirds are in a whole? Well, that's times 3. And then a half an hour, we'd have to do the same exact thing to the bottom. Remember, the same rule with equivalent ratios, right? Whatever you do to the top, you have to do the bottom. So a half an hour times 3, 1/2 times 3. Remember, look at this. It matches right up with our picture. And that would give us that 1 1/2 hour it will take him to mow his yard. All right, so there's a lot in Unit 5. Re-watch this. You can go back and pause it and redo the problems as you're going through them in the practice test. Take your time to really review all this and have a good understanding before you go ahead and do that Unit 5 test. And I wish you the best of luck on it, okay? Take your time. It's really, really important to work out these problems. These are types of problems where you can't just look at it and say, like, that one looks good, right? You have to work them out on paper, just like I took the time to work them out in this video for you. All right, good luck on your test, and I will talk to you soon. Bye, everybody.